Today I'm going to be going over Unit 2, Objective 1, Guided Notes Number 1. I like to start by talking about what we remember about slope. Slope can be thought of as the rise over the run of a line, the up and down over the left to the right. Sometimes we talk about the steepness. Sometimes we say the change in y over the change in x. Change in y over the change in x. A zero slope can be represented by a horizontal line. A negative slope is a line that appears to be decreasing or falling. An undefined slope is a vertical line. And a positive slope would be increasing. Question number 2 is talking about you're given two slopes, and we want to know which slope is steeper. Steeper means larger or bigger. And the sign of the slope does not matter. So if I look at these two slopes, it's easier if you look at them as decimals. 2/3 is the same as 0.67. 2/5 is the same as 0.4. So the steeper slope would be 2/3. Problem number 3. In order to win a carnival game, you must throw darts at balloons and hit 3 collinear balloons. Brittany throws her dart and hits the first balloon at 0, -2. Take a minute and plot 0, -2 on your paper. It is going to be on the y-axis. Her next dart hits the balloon that is 4 units to the left and 3 units up. So I'm going to go 1, 2, 3, 4 to the left, 3 units up. Plot this as point A on your graph. In order to win the game, what is the coordinate point of the third balloon that she must hit? So again, 4 units to the left, 3 units up. This coordinate would be -8, 4. Label this point B and connect the 2 points. What is the slope of line AB? Well, remember, slope is our change in y over change in x, or the up and down over the left to right. To go from B to A, I would first go down 3, and then to the right 4. So my slope is -3 over 4. Did the line of the balloons exhibit a positive or a negative slope? The slope is negative. In this next example, we can identify the slopes of the lines given. Looking at line AB, this is a vertical line. Again, we're going to be looking at the change in y over the change in x. You can see that this has a change in y of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. But the change in x is 0. Since it is impossible to divide by 0, we say the slope is undefined. CD is a horizontal line. Here you can see that there is no change in y, and the change in x is 3, 6. 0 divided by anything is 0. So CD has a 0 slope. ED is a negative slope. Let's start at point E. We go down 1, 2, 3, 4, 5, 6, 7, and then down 7, and then over 1, 2, 3. So my slope is -7/3. GF, line GF, To go from G to F, first we go up. 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2. 8 over 2, which can be reduced to 4 over 1. And you can see if I were to go up 1, 2, 3, 4, and then over 1, I would still be on the line GF. Okay, this concludes the review section of slope. In these first 3 examples, we're asking you to calculate the slope given 2 points. The formula is right here. So if I am given 2 points, I can label them. This is x1, y1. This is x2, y2. To find slope, it is the change in y over the change in x. In other words, it's the difference of your y values over the difference of your x values. So in example A, the difference of my y's would be 9 minus -3. And the difference of my x would be -10 minus -1. Doing the arithmetic, 9 minus a -3 is 12. -10 minus a -1 is -9. And we can simplify or reduce our fraction. And we would divide top and bottom by 3. We would get 4 over -3. I would like you to hit pause and now try B and C. Check your answers. You can see my change in y is 5 minus 5. My change in x is -3 minus a -2. That gives me 0 over -1, which reduces to 0. In part C, change in y, -3 minus 3. Change in x, 8 minus 8. That gives me -6 over 0, which is an undefined slope. There are 3 main forms in which a linear equation can be represented. The first one is slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. If an equation is in slope-intercept form, we can easily identify the slope and the y-intercept. Look at example A. Y is by itself, and we have our slope times x plus our y-intercept. This makes our slope -3 over 7 and our y-intercept 4. In example B, slope, remember, is the number in front of x. If you do not see a number in front of x, there is always a 1 there. So in this problem, our slope is 1. Our y-intercept, -9. In example C, there is no x value. This can be thought of as 0 times x minus 1, which means our slope is 0 and our y-intercept, -1. The next way to write an equation of a line is point-slope form, or y minus y1 equals m times x minus x1. The x1 and the y1 is any point that is on the line, and m is the slope. When you look at this form, you can easily identify what the slope is. However, looking for the y-intercept takes an additional few steps. Looking at part A, I can tell that my slope is 1/2. In order to find the y-intercept, I need to change this into slope-intercept form. In other words, get y by itself. All right, so first I'm going to distribute the 1/2. And then I'm going to add the 3 to both sides. And now it's in slope-intercept form. My slope is 1/2, my y-intercept, -2. Put the video on pause and try B and C. When you are done, come back and check your answers. Welcome back. You can see for part B that my slope is 1 and my y-intercept is also 1. In part C, my slope is 3 and my y-intercept is negative 27. Continuing, the next way to write an equation of a line is in standard form, ax plus by equals c. Standard form is most useful to find your intercepts of your line. We are going to take standard form and transfer it into, again, slope-intercept form so that we can easily identify the slope and the y-intercept of our line. To do this, you need to get y by itself. Look at example A. I want to get y by itself. First thing I need to do is add 2x to both sides. I get 4y equals negative 12 plus 2x. Then, to get y by itself, I divide everything by 4 and simplify. Y equals negative 3 plus 1/2 x. Looking at slope-intercept form, remember slope is the value in front of the x, so 1/2. And the y-intercept is negative 3. Put the video on pause and try letters B and C on your own. When you are finished, continue the video and check your answers. Welcome back. You can see that in problem B, the slope is 1/3 and the y-intercept is negative 4. In problem C, there is no y-intercept, so the y-intercept is 0. Let's look at number 9, which is a word problem. Mrs. Smith and Mrs. Washington are renting a car for their spring break vacation. The cost is $27.45 for driving 50 miles, while the cost is $31.95 for traveling 80 miles. What is the average rate of change for miles per cost of the rental car? So we are looking for miles per cost of the rental car. All right, well, we are going, the difference between the miles is 80 miles and 50 miles. And then the difference of the cost for 80 miles is $31.95 minus for 50 miles is $27.45. Do the arithmetic and you get 30 over $4.50 is 6.67 miles per $1. The next thing you need to be able to do is identify the slope from a graph. Okay? So looking at this graph, if you pick 2 points, you can count the slope. Remember, slope is the rise over the run. So from this point right here, I go up 2 and over 3. My slope is 2/3. The y-intercept of the graph is where the line crosses the y-axis, which is going to be right here at negative 5. So I can write the equation in y equals mx plus b form. Y equals my slope times x minus 5, which is my y-intercept. In our last problem, number 11, it's a little bit different. This is a vertical line. And you remember from the beginning of our notes that a vertical line has a slope that is undefined. And this graph is not crossing the y-axis, so there is no y-intercept. This does not fit into our traditional form for an equation of a line. There's no slope and there's no y-intercept. So to write the equation of a vertical line, it's actually x equals, and you look at what x value is being used on this line. And on this line, x is always equal to 3.